Hello and welcome to the show. My name's Relevant. This is Do All of the Things. On today's episode, I'm doing another upgrade modification to my HO track power supply, this time adding a multimeter to it so that I can manage my track power. Stay tuned. Or what I meant to say is monitor my track power. So if you've been following the comedy, you know that at some point I got bitten by the model train bug. And being the guy that I am, I couldn't just buy a power supply for the track. I had to build one. And here it is. How do I describe this? Well, it is a PWM power supply, and it has like kinda, I'm gonna say, digital switching on it, and it basically adjusts track power by changing the duty cycle. You know, all the usual stuff for switch mode power supplies, and it works so great, except for the switching. My switching's a little bit sketchy. But the first iteration of this used solid state switching, hacking MOSFET drivers to form an H-bridge, which kind of sucked. They lost a lot of power. So in a previous episode, I changed that out to a relay, and now I don't get power losses in the switching, which improved it greatly. But I also beefed up the output section with a bigger inductor and a bigger diode so that this thing can put out like 3.5 amps. So that's what this thing's rated for, 15.3 volts. 3.5 amps output. So far in using it, it's been very resilient to dead short circuits when your trains jump track and, you know, your metal wheels cross across them, bridge them, if you will, and then cause a short circuit. It hasn't completely blown up, and usually you can catch it right quick because you turn up the knob and your trains aren't moving. You're like, uh-oh, I gotta go fix a derail. But there was one more recent incident that happened where a car jumped track at the far end, and there's enough resistance in the track itself. The train still ran, but it was going slow, and I'm watching the train, and I'm like, just turning up the knob. There's no tactile indication on this. You gotta look at it to see what it's set to. And I'm just like, gee, my train's going slow. And then I look over, my knob's all the way up. It should be ripping at this point. And then I saw a little bit of smoke coming out of this thing. Now, I don't know, something overheated, but it doesn't appear to be damaged. So we're okay. She's still working. But I think if I had something like this, it would be easier to manage that. Now you notice most track power supplies, they have meters on them, a voltage meter and an amperage meter. And that's something this is missing. It's something I've always been wanted. So finally one day, while browsing the Bay of Ease for actually something unrelated, I noticed a seller I was gonna buy from anyway had these units on it. I purchased 3 of them. They're all essentially the same, just with different colors. And this one has more digits, and it's actually red and blue. They had slightly different measurements in the descriptions, so not knowing exactly what size would fit in here, I bought them based on their size variety, but after having received them, they're all about the same, with the exception of internally. 2 of them are exactly identical internally. They just have different colors. This one, which is actually the 200 volt rated one, it's a little bit different. Like, it's very similar, but a little bit different. They all have the same pinouts. This one's longer because its amperage thing, current sense link, if you will, is sticking out more for whatever reason. But other than that, they're all about the same. So I could pretty much throw whichever one I want in here. So having pre-measured before purchasing this, I determined that I should be able to fit it right here. And in measuring internally, they almost seemed like they wouldn't fit, but now that I'm seeing it, it's like, yeah, it's totally gonna fit. So this prong here would interfere with that capacitor if it wasn't for the fact that this prong's gonna be like back here. So this should fit just fine if I plop her right there. And because they're the same footprint, I don't even have to make up my mind which one I want to use right now. They're all gonna work. So buying 3 of these, I wanted these anyway. I keep having projects where I'm like, I wish I had just like a little voltmeter, amp meter to chuck in there. So finally, boom, here we go. I got a few for other projects. Now, upon initial inspection, we see that I do believe, was it this one I took apart? This one? We could just pop these. I thought I could just pop these right out. Yeah, just like that. Pull that back, push it from the front, and it pops right apart. We got a little viewing window. Oh, they still have, the, some sort of cover, little plastic cover on the LEDs. I'm gonna leave that. But boom, now we got this guy. So that makes it easy because now it's flat. I can just kind of sit it here where I think I want it and outline it. I almost wish I could fit 2 of these in here and then have input and output, but that's not happening because, well, there's no room here. So I guess this is gonna go right about there. Now, one of the hardest parts of this project is going to be fashioning a square hole. As you can imagine, I don't really have the tooling for that kind of thing, so this is gonna be somewhat experimental. The great thing about pencils, you can erase it, unless you're on this textured surface, it's kind of difficult. So that should be fine right there. Obviously, before we go drilling into this thing, we got to take her all apart. Like, we're not going to be able to drill with the power board in place. And oh boy, I forgot that this is not easy to take out because there's solder joints that we have to undo. I'm going to have to take this power board out because this is where I'm going to tap the signals to determine what this is doing. And I do believe my 632 wrench is upstairs. I forgot. I have a diode on the back here. Oh yeah, the trickiness of my installation. That part I thought I had soldered on the board is no longer. So there's the catch diode on the back mounting directly against the case for heat sinking, even though it doesn't seem to get very hot. Instead, the MOSFET hiding under there gets hot, and maybe it should be sunk against the case. That ship has kind of sailed in this layout. I'd have to completely relay out this board to do something like that. I'm looking at this, trying to see if I could determine where that smoke might have come from. I'm assuming it would have been the MOSFET. That's about the only thing on here that could get overloaded in a dead short circuit. The diode gets overloaded with load, and this guy doesn't care as much, so oh well. We should be clear to work on this now. I might be able to connect this to the power supply board because it has the facilities. I wanted to use this board because it has 12 volt regulation to control the relay. So I would operate this off that 12 volts. These guys have a wiring harness that looks like this. So this 3-pointer here is you have your operational power to power the actual meter, positive and negative up to 30 volts according to these guys. And then this is your actual detect. This is where you want to detect the voltage. Now you can't just directly hook these up to the track because they only work on one phase, and I even kind of tried to test it. See what happened if I reverse the phase on the sense here, and something got hot. So let's not do that. We need to put this before the switching. And then this guy with the bigger, beefier wires, 18 gauge rated, so I guess at this length, 10 amps, it could do that. That's for our current sense. Now, that all makes sense to tap off the output board. It has all the facilities. We could theoretically do it on the power supply board too, though. And this is, you know, phase dependent, but you could put it on the negative side. You could have it like negative out, then this positive wire to your other negative out to the track. Or you just put it on positive side and then that goes to the track. I'll worry about that later. In the meantime, how to get holes into this. A square hole. One common trick is to drill a bunch of smaller holes. Sometimes I cheap out drill larger holes, but we have a bit of flange to work with, so some margin of error. I think a 1/4 inch bit might do me. I'm just kind of eyeballing initial alignment here and scoring these initial corner points. So I'm kind of putting the bit in such a way that this edge and this edge line up with this edge and this edge. That should get me pretty close to what I want. Now bear in mind, this is not a how-to. I'm not an expert at doing this kind of fabrication. We have 4 points. All right, that's a start. Gonna draw a line between these 4 points. That should give us alignment points in which to, pilot points in which to keep this 1/4 inch party going. Gonna mark the edge of the bit here, move over, score another, move over, score another. Not enough room here to score. I'm gonna do the same thing on the other side. Need a little bit of an overlap. Looks like it's gonna line up well this way, pretty even. I got it a bit tight here. This is aluminum, which means it'll drill easy, but it might also gum up the bit even easierly. All right, well, I'm gonna bust out Mr. Pressy Boy here. Ho, we have just enough room on here with the thing all the way down. Okay, well, can I arrange this deck so that I have support of this thing? Yeah, okay. This should be doable. Wish me luck. Oh, look at all this spaghetti. Hey, keep moving. Okay, so I'm not too practiced at this method of fabrication. This is probably the least worst I've ever done it. Little bit of it didn't quite work here because it was too close. I need to clean up a bit and then move on to the next stage of the operation. Oh, it's all over me. Okay, so now what? If I just kind of snip on these, would that yield results? At least to get the main core out, yeah, probably. But not necessarily with this guy. Gonna need something a little bit more prolific here, bud. Okay, that's out. Now we have to make this whole square, which in the past I often did with a lot of filing. I'm gonna see how far I can get with filing. I got like, you know, a rotary tool, which would make quick work of this maybe, but it would also fling crap everywhere. Yeah, I'm gonna try the rotary tool. I'll say, but I'm so happy they make these cordless now. Ugh. It is hard to line up a cut because as soon as you look in line, it's just crap is just right at your eyes. It's yeah. All right. So like obviously we got to finish this with the file. So we have roughly a square hole by now. Let's see if we can pull these burrs off the edge. Oh, got more inside. So let's check some rough fitment here. Oh boy, it looks like it's ready to go. That's great. All right, let's clean up once again. So for my first Patreon giveaway, this scrap piece cut out of here. No, just kidding, unless you really want it, I guess. Well, you know what, this will probably end up in the garbage long before this video gets posted, so. Now, one question on my mind is how successfully can I erase? Oh yeah, okay. All right, so 1, 2, 3 of these things. Which one do I want to use here? I gotta kind of figure out, they're not labels. I don't know which one's which. Now, if I power these off a 9 volt, I should get something out of them. Oh, yeah, that one's green and red. Oh, it's blinky in the camera, which means this one's red and red. And as much as I like red on red, I think I want the green one because the green is the amperage and it's really gonna jump out. Yeah, that's the red on red one. And this one should be red on blue. Oh, I wonder what the advantage of this guy is. This one kind of looks cool. It's got some relatively high resolution display there for, so what happens if we give it a signal? 9 volts, 8 volts, 8.87. So top is voltage, that's gonna be amperage at the bottom there. Well, seeing as how they can be roughly swapped out, I'll determine that later. Meantime, I can get this put back together, if I can remember which side's which. Uh-oh. Okay, well, as an estimation, aha, controls are on this side, which means this way is up, and then it will be volt amp like this. All right, that's back together now. So it looked like it was gonna fit. Now, it depends on these guys squishing in, which they can't because LEDs are blocking it. Interesting, interesting. Okay, we have a curveball here, but an easy one that I think I can solve in short order. If I could find the frickin' tool that I need. So we'll pull this back. We will remove the display again. Then we'll try to pop in the bezel. Yeah, okay. Then we insert the display, and I guess that'll lock the bezel into place. All right, it's in there. Nice. And it looks relatively clean around the edges. You can't even tell it's a hack job underneath. I just want to power it real quick to see how it's gonna look. Ah! Oh yeah, Christmas, nice. And ooh, that's tight right there, bud. That, oh, is that gonna be a problem? Okay, fortunately there's not much going on there, so no, we can slip this right over top there. So yeah, it's all gonna fit together for the most part. Little bit of congestion with this connector down here. That's the power input. But now I gotta figure out where to tap it into to get the signal we need. So right here is the relay-based output module, and I already see a flaw with the design that tells me I can't connect this to it. So the idea was, we have power coming in here, which is just basic power to power the relay fire circuit. It's not the track power. And then it has some input filtering, then it goes to the voltage regulator. We just have our 0.1 output filtering, then it goes right to the relay. We would need a bypass capacitor there, like another 10U, I guess, if we wanted to run the circuit off of this, because well, when the relay fires, it might mess with the circuit. Also, that output, that regulator is only rated for 100 milliamps. It says that this is rated for about 20. And I can't expect the relay to consume more than 30 milliamps. We should look it up real quick. So, general purpose relay, blah, 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 datasheet. 12 volt coil, 400 milliwatts. Because it's a 400 milliwatt coil across the board. So with different voltages is a different power draw. Sometimes in the datasheet they just straight up tell you, but it doesn't look like they do. We got to calculate 400 milliwatts. 3 milliamps? No, 33 milliamps. So 33 plus 20 is, that's about 50 milliamps. I guess the regulator could run that. Question is, will power surges from the relay mess with the circuitry? These guys are mostly self-regulating. Like they're rated for 30 volts because they're gonna have their own regulation onto it. So I'm guessing, screw it, we won't use the regulated power supply here for the relay. We'll just hook it up to input power. They're rated for 30 volts. So as long as I don't plug anything more than 30 volts into this, I should be fine. I think 30 volts is my theoretical max for this anyway. I think other things are gonna be frying out. Like I'll fry the regulators in this. I'll fry my MOSFET driver if I plug more than 30 volts into this. I designed it for 20, so that's one thing. Now, where are we gonna tap power? So before switching, we need to get the power that is going to the relay or from the power supply. I think ideally, well, one of the easiest ways is to just intercept the signal going between the boards. That would be this guy here. It's very tempting because I have the power supply board sitting right here. It's getting full input power here, output voltage signal somewhere here. I think it will just be easier to tap off the power module. Its layout is here. So it might be easy to put current sense on the negative because we have this long arm here. We can disable that and put the connections for the current sense across here. That'd be the easiest way. And then we have room here to tack on an output power lead. And then we get general input power from over here, or even right around here. Oh yeah, there's a convenient spot right there. Okay, I think I have a plan now. I gotta fire up the old heat iron. Should I get these wires prepped a little bit more slack on them? So I think I'm gonna connect my power here and here, and then bridge this over. That's the wrong color trace. We'll get our negative from here because there's like a little tiny gap where the trace goes over. So I can just wrap it around that. And then the other one, just tack it over to this bus line here. So yeah, that'll be positive, that'll be negative. And then well, around here, pretty self-explanatory. I just got to undo all this. I'm surprised my vise goes this wide. Grab the negative bus there, just wrap that down over. Confirm, yeah, that is supposed to be the negative. Tack it on. Positive wire up here. And we just give it a reach around. Can secure it into this hole. And then we have to melt this solder bus here. Now we should have positive power. Now our voltage sense, that's gonna go like, I guess, right around here. Oh, it's a little tight in here, eh, bud? That'll do. Now the voltage sense is a little, there's actually a better spot for it right in here. Yeah, because it's coming right up next to that trace. See, the power input for this thing, as long as we get enough voltage to it to work, it doesn't matter. But for the power sense, we kind of want to see if we can maintain a better quality connection so we can get a more accurate reading. But that should be good there. All right, so we put the connection like right there. And I should have done something pretty to like, I guess we could just do a twist now. Sometimes it's nice to braid these triple cables. Okay, it's not the nicest twist, but it'll do. So now current sense. So we're putting it on the negative. That means I have to delete this general trace here. I need to pull it up. Okay. All right, so now it's pulled up. Now we gotta get this thing, the red wire. So to current sense on the negative, the black's gonna be input, red's gonna be output. Should be no reason why we can't do it that way. Other than these wires are too thick for this hole, so we gotta widen them. I didn't bring down my hand tool. Actually, that might be a bit too close to the plastic connector. Yeah, it is. Okay, can I still get the wire through? Yeah. All right, well, that'll be fine. Now it's just a case of getting a nice connection to this pin without touching anything else, which I believe I can do if I get rid of their tinning at the end. So I need to strip a bit more off. All right, get that wrapped around. Oh yeah, this'll work, this'll work. This will work quite well. All right, tack her down. Now I just need to get that black wire on here. Hey, that black wire just needs to combine with this negative bus here, which is kind of oversized for the application now. Hey, so we're just chonking it all together here like that. This should work now. Let's see if we can test it before we get it all buttoned back up. So, input power to this, control power to this, control pin, output power to this little short wire here. Then we'll use one of our loose meters. There and there. This should work now. Got this little AC adapter, puts out 20 volts, 900 milliamps, which is good for testing because it means you don't have enough current to fry stuff. But, okay, everything kicked on. I got a reading. If I turn up the knob, it should start telling me voltages. Oh yeah, bud, there it goes. It goes to 14 volts in short order, and then it takes a while to come down because there's no load. Got a little 12 volt bulb here I use for testing this thing. Well, you know what? Let's put it back together and then test it because we know roughly our connections are good now. Now fixing the diode's the tricky part. So dish goes in there like that. And then the diode, used to be this was soldered onto the board, but it looks like it didn't stick. Got to kind of hold this on with tweezies. Ah, you know what? That was easier than I expected. All right, snug her up. Always a bit loose because we can't get a wrench in there, but it should be holding that diode down enough to be tight. Oh boy. I gotta figure out where my nuts are. I dropped my nuts. Oh, they're right there in my hand. This one's not easy to get into place now with that thing. Ugh, we got logistical complications, sir. Okay, I got it. Let's just tighten up our nuts now, bud. All right, plug it all in. So the power input is tight down in there. Yeah, this could be tricky, I don't think. Okay, it's fine once we get it in. And power output, control signal. Our amperage lead is way too big now. In retrospect, I could have cut that shorter. And then our voltage lead. So that should be all together now. Give it some power. Everything's there. Where's our little light bulb? Secure down our test load. Oh boy, there we go. Look at that. This bulb's rated for about 250 milliamps. So yeah, we're getting amperage readings now and voltage readings. This is great. And it shouldn't matter what phase we're using now, whether the train's going forwards or backwards. It's telling us what it's gonna run. Nice. All done. That is great. So, might just go up to the track and test this out real quick. Before I do, I hope you enjoyed this. If you did, stay tuned, because I like to do things like this. Not all my videos will be train videos. Not all my videos will be computer videos. Not all my videos will be circuit videos. I might jump a dirt bike in the next video. I don't know. Probably not likely. But anyway, thanks for watching. Stay tuned. I already said that. Yeah. Okay then. That was fun.